Hello everyone, I'm BLACKNED. I'm here today to tell you about how physics applies to video games. That's right, video games. Not only do we see physics in everyday life, but we even see it when we turn on our game consoles and play a video game of our choice. Today, I'm going to show you how the laws of physics apply to Halo Reach. Let's first start with the basics of physics. They are Isaac Newton's 3 laws of motion: inertia, acceleration, and action versus reaction. Let's start with inertia. Newton's first law states that an object in motion will stay in motion, and an object at rest will stay at rest until a force is acted upon that object. Let's take a look at the mongoose here as an example. The mongoose is at rest, yet it's not going anywhere. It's staying at rest. It's not until the driver applies the force of the throttle of the mongoose to put it into motion. And as long as the driver holds down the throttle, the mongoose will stay in motion. But if the driver applies the brakes, the mongoose will slow down to the force of friction, and now the mongoose is at rest again. Newton's second law states that a body of mass subjected to a force undergoes an acceleration that has the same direction as the force. Here, Daryl is at rest. He's just standing still and the force is 0. But if he applies the force of his joints, he can put his body into motion. And if he increases his velocity and accelerates, he will increase the force as well. But eventually, he decelerates. And has to come to rest once again after a long sprint, therefore making the force 0 once again. Yes, Daryl, perhaps you should take a break from the marathons for a while. Newton's third law states that for every action there is an equal and opposite reaction. Right now, the scorpion tank is being pulled down on the ground by the force of gravity. But at the same time, the ground is pushing back up on the tank. But it's an equal amount of force, so the force is 0. Same thing with the Spartan. He's standing on top of the tank and is being pulled down by the force of gravity, but the tank is pushing back up on him. Still, equal amount of force, so there is no movement. The force is 0. However, if we switch the Spartan and the tank around, since the tank has more mass than the Spartan won't be able to push back up on the tank. Therefore, the results can be quite fatal. Now that we've covered the basics of physics, let's look at some of the other properties of physics that are within the game of Reach. Many people think mass and weight are the same thing. Well, guess what, people? Wrong answer. But how can we tell the difference? Let's find out. Mass is the amount of matter in an object, while weight is the gravitational pull on an object. For example, here in outer space, there is no gravity. My body is weightless, but it's not massless. Therefore, I can do this. Whee! Now that that's covered, let's talk about momentum. Momentum is the measure of the continuation of inertia in motion, meaning the momentum of an object is equal to the product of the mass and velocity of the object. The greater the mass, the greater the momentum. Momentum is the main method in describing collisions. There are two types of collisions, elastic and inelastic. An elastic collision is where no kinetic energy is lost after the impact. Here, Colton is going to throw a plasma grenade at Neil at a velocity of about 5 meters per second squared. But when Neil deploys his armor lock ability, it will bounce off of him at the same velocity of 5 meters per second squared. No kinetic energy was lost. Elastic collision. An inelastic collision is where some kinetic energy is lost after impact and is transferred to the other object. One of the most common examples of inelastic collisions is car crashes. After the impact, the energy from the Revenant was transferred to the Warthog, therefore putting the Warthog in motion as well as damaging it due to the force of the impact. Hence, inelastic collision. Free fall is motion under the influence of gravity. The velocity of gravity is 9.8 meters per second squared. Here we have Sargent, who is atop the high dive. He is going to free fall into the ocean below using the force of gravity. Let's watch and see. However, if the force of gravity is misused, the outcomes of freefall aren't quite successful. When Sargent was free-falling, there was a force of friction that was preventing him from reaching his terminal velocity right away. And that force is air resistance, which is why a rock will fall faster than a feather. Here we have a ghost and a warthog ready to race. But who will win? Let's see. The warthog is much faster than the ghost. Why? The answer is simple. The warthog has wheels that make it come in contact with the ground, giving it traction, and it has less friction. The ghost, on the other hand, is hovering in the air and makes no contact with the ground, making it vulnerable to air resistance, hence slowing it down. So how does the ghost overcome this problem? The ghost has been equipped with a boost mechanism to help decrease the air resistance, and therefore to help it outrun the warthog. Now we shall talk about different types of motion. First, there is projectile motion. Projectile motion is the motion of such a projectile, and the path followed by a projectile is called its trajectory. How does this tie to reach? Let's take a look. Here, Neil has a grenade launcher, which he will fire the rounds at different angles to show how the projectile is affected by gravity. His first angle is a horizontal at 0 degrees. Not much distance. But what if he fired it at 45 degrees? Huge difference. That's because 45 degrees gives us the best distance, because the sine and cosine of 45 degrees is the exact same. But what would happen if we fired the projectile in outer space? As you can see, since there is no gravity to pull our projectile downward, our projectile will continue forever and ever and ever. The other type of motion we have is rotational motion, which is the motion around a fixed axis. One example is the rocket launcher's auto-targeting system. Once an enemy passes by, the rocket launcher will lock onto its target and send the rocket into a rotational motion around its target, hoping to take it out. Thanks to rotational motion, our Spartan was able to neutralize the enemy Banshee. Finally, we have the center of oscillation. You're probably thinking, what in the world is that? Well, it's the point on an object where a perpendicular impact will produce translational and rotational forces, which perfectly cancel each other out at some given pivot point, so that the pivot will not be moving momentarily after the impulse. Let's take a look at an example to help me explain. Here we have a rocket launcher and a gravity hammer. If Cody wants to deflect the rocket from Stealth's launcher, he will need to hit the rocket at the center of oscillation on the gravity hammer. Can he do it? Let's find out.
Swing, batter, batter, swing. Swing, batter, batter, swing. Batter, batter, swing. Batter, batter, swing. Yeah.
As you can see, the gravity hammer is like a pendulum. It has a center of oscillation. However, if the hammer didn't have a center of oscillation, this would have been the result of Cody's stunt. As we can see, physics is very important when it comes to video games, because without it, the game just would be completely unplayable. Thank you for watching, everyone, and remember, physics applies to our everyday lives, whether in the real or the digital world.